So good morning, everyone. So thanks for having me here today. And so my title is Improving Predictability. First of all, I'm a postdoc with the Hydroinformatics and Integrated Hydrology Research Group at University of Nebraska, Lincoln. The group was led by Professor Francisco, and this work was primarily carried out by Alessandra, but he is now in Europe, so he cannot give out this presentation, so I'm a replacement, kind of. So this presentation is give you a general idea that what we have in Nebraska and what we are going to try to do and what we are doing now. So we have many data. This is the same problem like everybody have, and what are we going to do with those data? So we have the remote sense data from the above. We also have ground data, pumping data, and we have the irrigation data, and we even have the the soil moisture data at very high resolutions. So in Nebraska is the first, the one of the largest irrigator in U.S. We have like over 100,000 registered irrigation wells and 80 climatological station, and 8.56 million irrigated acres and 4 million rainfed acres. So 80% of the irrigation system are sprinkler system, and 98% they are center pivot. Half of the center pivot use electricity, and a third of them use diesel. And now some of them they are transferred to solar power. So the data was predicted to grow exponentially in the future. So what are we going to use those data, and how can we use those data to more efficiently use energy and water to grow our crops? That's what we want to solve. So we are kind of at a baby stage of machine learning. So these are the very first stage research we conducted. So we use artificial networks, and we use the climate data and the crop water demand and groundwater level, previous groundwater level as the input for this artificial network model, and then we generate the groundwater level in the future. So the beauty of machine learning is that in the past we have hydrology model and we have crop model, and those model is like hundreds and of thousands of lines of source codes that you have to debug it, to learn it. But now it's like 100 of MATLAB source codes. So using this model, we are trying to identify the semi-seasonal and seasonal water levels. So we also test that how the crop water demand will impact our model. Like we run it one without the crop water demand, and one model with the crop water demand. So we found that the Nash efficiency, which is statistics of the model performance, will improve, like not remarkably, but like noticeably, like with the crop water demand, which means that the model can somehow identify the crop water demand impact for the groundwater level. So the future is to address semi-seasonal to seasonal need of water-related information agriculture, and also to do the statistics and ensemble analyze and quantify the uncertainty in rainfall and water use, which are the inputs for our models, and also generation of the graded groundwater levels spatially and temporally. So now we only apply it to like predict one location. We are going to apply this technique to all the like many locations and see the parameter, the distribution of the parameter has a pattern in these models. And also coupling the forecasting system with a crop growth model to optimize the water supply. Okay, thank you. Yep.
Thanks. So what's the structure of the neural networks that you're using to predict? Was it just like a one layer?
I think it's 3 layer.
3 layer?
Yeah.
Have you, so I've done a lot of work in time series data prediction. Mm-hmm. Have you looked into any recurrent neural networks or any of those techniques?
I'm not sure because it was Alexandra do this research, and yeah, you can contact him about that.
All right, that's fine.
Sorry about that.
Probably have time for one more. Oh. All right, well, thank you.